6, and it reads, in a study done on life expectancy of 500 people in a certain geographical region, the mean age at death was 72 years and the standard deviation was 5.3 years. What is the probability that an individual selected at random will be less than 70 years old?
So in problem A, if it says less than, then that means then you will have to use the equation -10 raised to 99 times B times the mean and times standard deviation. But you have to do the normal CDF. And in this case, normal CDF means if a variable has a normal distribution, then you can use this button by pressing the second button on your calculator and then variance. And it will give you the probability that the variable will fall between the two intervals that you have. In this case, B is 70, and the mean is 72, and the standard deviation is 5.3. So when you multiply that, you get 0.3529, and it equals 35.2%.
If a sample of 50 people from this region is selected, find the probability that the mean life expectancy will be less than 70 years old.
So similar to A, B is still saying that it's less than 70. So the only thing that changes in this problem is B. So our mean will always be the same, but our standard deviation changes because we have a different sample number. And we will use the equation SD equals Y equals the standard deviation over the square root of N to get our new standard deviation so we can find our answer to our problem. And we will use a normal CDF function on our calculator where we will plug in our new standard deviation and we get 0.0038, which equals 38%. Sorry, correction, 0.38%.
Go.
In your own words, explain so that someone not in this class can understand why there is a difference between Part A and Part B.
So the difference between A and B is the sample size changes, so the standard deviation theoretically changes, but in this case, our mean stays the same. Yeah.
Which makes A and B different.